So next is to get the value of series circuit resistors. So we have here the examples that needed to be answered. So the first question is, how can we calculate the current that flows in a circuit? So as you notice that every time we will solve any circuit problems, the first thing you need to look is the to calculate the circuit. I mean the current. So by getting or calculating the current that flows in a circuit, so let's say that we have two resistors, and first one we have 4 ohms and the second is 6 ohms. Then we have volts of 40 volts. So now in this problem, the first thing you need to do is to find the total resistance. In the series circuits, it's simply R1 plus R2, so 6 plus 4 equals 10. So equals 10. And then uh, the next thing you need to do is the use the Ohm's law. So V is equal to I times R. If you use the 40 volts and the total resistance of 10 ohms, the current that flow to the circuit is 40 divided by 10. It will be 4 amps. So 4 amps of current leaves the battery and flows through each resistors. So next question is, what is the voltage drop across each resistors? So let's start with the 6 ohms resistors, and to find the voltage across it, of course we will use the Ohm's law. So number 1 is uh, V equals to I times R, so equals to 4 times 6, so we will get the voltage of 24 V. But do not forget to write its symbol. So now what about the second resistor, which is the 4 ohms? So use the same equation, which is we have V equals I times R equals the 4 times 4, so we will get 16 voltage. So we have 18 voltage across the 6 resistors, then 12 volts across the 4 resistors. So is, what is the power delivered by the battery and the power absorbed by the resistors? So power is equal to voltage times current. So P equals V times I. So we'll get 40 times 4 amps is equal to 160 watts. So the battery delivers 160 watts of power. Next question is, what about the 6 resistors? So let's use the second form of equation, which is P equals I squared times R. So it will be 4 squared times 6, and we will get 96 watts of power. And then the fifth question is, what about the 4 resistor? So they say so let's use the third form of equation, which is the P equals V squared divided by R. So it will be 16 squared divided by 4. Then we will get the 64 watts of power. So at this case, we have 64 watts of power in the 4 ohms resistor. So after this, we will add up all the power of the two resistors, and we will get 160 watts of power. And lastly is the value of parallel circuit resistors. So we have also here an example, uh, a circuit with two resistors. So now we have 25 volts, and the first resistor would be 5 ohms and the second is 8 ohms resistors. So we have the first question is calculate the current that flows through each resistors. So let's use this equation, which is V equals I times R. So the voltage here obviously is the 25 equals I times 5. Yes, the 5, or the first resistors, and we will get 5 amps. So 5 amps. So second question is, what about the 8 ohms resistors? So V equals I times R. So the voltage 25 equals I times 8 ohms. Then we will have 3.1 amps. So let's find the current that flows through using the same equations. V equals I, the voltage of 25, and the resistance is 8, is divided by 25 by 8. So the result is 3.1 is current flow through the 8 resistor. So 5 plus 3.1 will have 8.1 amps flows in this direction. So we have the third question, which is we need to find the equivalent resistance and the power delivered by the battery and absorbed by the two resistors. So the first thing that we will use is the Ohm's law, which is V equals I times R. So the voltage 25 equals 8.1 amps. The total resistance, the total flows in the direction. So we will have 3.8. So the equivalent resistor is 3.8 ohms. Fourth question is calculate the power delivered by the battery rather. So as you notice in the series circuit, the total current is increasing, while in the parallel circuit, the total current is decreased than its resistors. So now let's calculate the power delivered by the battery. So number one, P equals V times R. So it will be the voltage 25 times the I, which is 8.1, equals 202.5 watts. So, but in the 5 ohms resistors, we will have P equals I squared times R. So we will have 5 squared times 5 equals to 125 watts. And lastly, resistor, which is the 8 ohms resistor, let's use P equals V squared divided by the R equals 25 squared times the 8. So we will get the final answer, which is the 78.2. And that would be all. Thank you.